Hey, lady and gents. So today we're going to look at 2.6. You can always help me solve this or view an example. So I'm just going to go real quick through this. Talk about some definitions like continuity need to be continuous. So if you have a continuous function, you can draw it without lifting up your pen. Something discontinuous will have a jump in it, like this, or it could be a bunch of jumps. But if it's continuous, it's smooth and curved and not necessarily curved, but it doesn't have any gaps, no jumps. So it's nice and continuous. So which one of these is not continuous? Well, this guy with all kind of jumps. If you can't see it, make it bigger, pop it out, whatever. Bunch of different jumps here. It jumps every integer. So A. Now it asks for the range. Well, it gives you multiple choice, thank goodness. Is it all real numbers? Well, look at it, is it? No, it doesn't include anything between the integers. It's just the integers. The integers is my range. So which one of these says the integers? This one says the integers. So it's a polynomial. This is a cubic function. They're continuous everywhere. Negative infinity to positive infinity. There. I want to get to some piecewise functions because I don't know if y'all talked about piecewise yet. Okay, where's this guy continuous on? So this is a better example. Well, it's not continuous before it starts. Now it's continuous on the interval. Well, where does it start? Does it start at 1? Does it start at 3? 1. X's, guys. Talking X's here. It does include it. So better use a solid, nice little bracket there to infinity. Here we go. Piecewise functions. So sometimes you'll have a function that's just a bunch of different functions shoved together, but only part of them are graphed. For instance, this right here would look like this line as long as x is less than or equal to 2. Once you get to 2, you stop right there, and then you go to this line. Between 2 and 8, not including, so there's no line in there, it doesn't include those. It looks like 4x. So this has a -2, so this is a 4 slope. So the first one, I'm just sketching an idea of what this could look like. It's going to look something like this from negative infinity until 2. And then it's going to start going up and at steeper rate than it was going down. And then when it's greater than or equal to 8, it's going to go even steeper, but still positive. That's still too steep. Let me change that so I can actually draw the next part. And then it's going to do something like that. Not straight up and down, but whatever. You get what I'm saying? Hopefully you get what I'm saying. Something like that. So that's what this will look like. It's a bunch of things just shoved together, and they might not even be connected. There could be gaps. There could be jumps. You got to check. For now, though, we're just evaluating. So if I plug in -3, well, which one do I plug it into? Is -3 bigger than or equal to 8? Is it between 2 and 8? Is it less than or equal to 2? That's where you plug it in. Get the face out the way. 4 minus 2 times -3. And we get 10. We put 10. 0. Is that less than or equal to 2? And I don't even need to type anything because that's 4 minus nothing is 4. 4, is that less than or equal to 2? Is it between 2 and 8? 4 times 4, 16. So I plug that one in the middle equation because 4 is between these two numbers. 7. Is 7 between 2 and 8? 4 times 7, 28. 8. Is 4 between 2 and 8? This is both 8. So they both have an 8. Which one do I use? Oh, the one that includes 8. This has the equal to part on it. Use that one. 43 if you use a calculator. All I did was 5 times plug in 8 plus 3. 43. Oh, here we go, graph. So like I was saying earlier, it's a graph. So what does this piece look like? What does that piece look like? This piece has a positive slope. So I'm looking for something that starts out going up, increasing. This is decreasing. This is increasing. This is constant. This is, oh, here's my answer. But let's just make sure. And then it's constant after that. It's -4. Oh, yeah, that's definitely it. Let's talk a little bit more about this. Actually, let's get a similar one. Maybe it's different. Let's see if we have any different styles. Gonna be looking like that. Okay, well, that's easy. So again, we got a positive slope and then a constant. Negative slope, there's positive slope and then a constant. There we go. Okay, this one's more interesting. Well, if we look at it, I'm just looking at the slopes. See, coefficient of x. Negative slope, positive slope. That's easy. It's going to go down and then up. Do they have to be connected? Not necessarily. It's going to go something like this and then this. Well, this. Something like that. Or it could be like that. I don't know. I don't know. But it's down then up. It could be this one. That's up then down. That's down and down. That's up. So it's got to be A. So let me look at that. Let's look at another one. Negative, positive. These don't have very varied problems. These aren't interesting. Oh. That's one. Okay. Whatever. So look at these slopes. Look at what they are first. It's a line. It's linear. So you should have a line, and you should have a line. This is a line going down, negative slope. This is a line going up, positive slope. So that's what you're looking for. Line going down, line going up. That's the only one like that, so you don't have to do any work. Okay, we got 3 of them now. So let's just think about what this is doing. Positive slope, going up. Negative slope, so it's going up, then it's going down. Positive slope, up, down, up. That's down first, that's down first, that's up, down, up. Could be this one. That's up, up, up. So yeah, it's so easy. Just look at the slopes, guys. Don't even have to do any work. So this should take you like 2 minutes, and then you can try and do the quiz that you're supposed to do yesterday. I know you 3 at home people did it. Ethan, do better. Other 2, okay. Oh, more interesting, more interesting. Yay, it's something different. We've got an increasing linear function. We've got a constant linear function. We've got a quadratic opening up. So you need to know what these things look like. You need to know your basic mother function shapes. If you don't, you always just throw this in Desmos. Let's grab Desmos. Maybe you can do the whole thing. I've never tried piecewise on Desmos. And if you have a TI-84, you could use that. I wonder. So 5x, -5, and x squared, oops, okay. I'm not super familiar with this. I don't usually use Desmos, but here it is. So you can get a picture of each thing, so what they look like, and -1 to 0 here. Let's see if this works. Oh, that's not gonna work. I don't know what that is. Comma. No. I'm just playing around with this. I don't know. I'll see it. Oh well. So you can at least get a picture of what each of these things look like. You can see that this is a line going up. You should start with a line going up. You can see this is a constant line down here. That's the thing in the middle. You can see this is an opened up parabola. So you can at least graph them like that. I'm sure there's a way to type this in there. I don't know. You can play around with it if you want to. I don't feel like it. But it's got to go up, constant, and then an opened up parabola. Oh, there it is. Let's make that bigger. I think that's it. Up, constant, open up parabola. Okie dokie, I'll take you. Oh, hey, we have to figure out what this is doing. Okay. So notice there's an A and a B option. That matters. Look at the difference. The inequality symbol. It's less than or equal to start, or it's less than to start. Well, we're American. We read left to right. We're going from left to right. Is this included or not included? It's included. So I need to start with equality. No. Yes. Okay. What is that number that x is? 2. That's where it's jumping, right? So these are both 2. Now, what is this thing? What's the equation of this? I don't know, let me make it bigger. I have no idea. Oh, wait, that's just y equals -1. And then that's just y equals 1. So that's -1, and that's 1. Wow. What's the domain? Domains are x's. It goes forever that way, and it goes forever that way. So the domain's everything. So I'm going to type it right here, right? Maybe. Oh, wait. Why is it a curly bracket? Why does it say comments separate answers? Because that's the wrong box you're checking. Put it in here where it says interval notation. Make sure you choose the right box or it will mark it wrong. Now the range. It's not going up and down. It's just -1 or 1. So I'm going to do that right in here. I need set notation. -1, 1. There it is. And then it is the next question. I have no idea. How do I find the equation of a line? Find the equation of a line. So again, check. Am I starting including or not including? On this one, I am including again. Let me check. I think it changes sometimes. That's including, that's including. Okay, maybe it doesn't. I don't know. These might swap around. Just check. That includes it. So make sure you choose one that has less than or equal to. And where's it jumping at? X is 1. Now this one, the equation afterwards, greater than 1, that's 3. That's super easy. This one, though, I'm going to have to look. Y equals x plus b. Yeah, so what's my m? Slope, rise 1, run 1. Rise over run, 1, 1. Y-intercept, b, 0. So it's just 1x plus 0. Oh, that's just x. The domain is everything. There's nothing that we don't include on the x's. So I'm going to type it right here. Oh no, I'm in the wrong spot. Type it down here where it says interval notation. You can click the button so you don't get confused or whatever. There's an infinity button right there. I just like clicking it. The range is, well, this time the range isn't just a number, is it? It's negative infinity up to 1. But then it's also 3. Oh, it's multiple possible answers. So is it just some numbers you're going to stick in there? No, it's this one. Negative infinity all the way up to 1, including 1. It's also the number 3. Look at it. It's going up, up, up. So it's all the way to negative infinity. So it's up and down here. Negative infinity all the way up until 1. It stops, and it jumps up here to 3. Done. That is it for 2.6. So shouldn't take you too terribly long to get through. And if you do get stuck on something, you can view an example, help me solve this, whatever. And if you're still stuck, mess me on Google Classroom, it's fine. Bye.